Well, welcome back. We are on 7.3. We're going to be talking about percent change today, specifically and how that relates to exponential functions. So we're going to start off with a definition. Percent change. Basically, it's how much something changes viewed as a percent. I mean, that's pretty much as easy as you can make it. What I would like you to do is think about what happens when an exponential function has a base of 1, which makes it not an exponential function. But let's look at an equation here. Suppose we have an equation and the base equals 1. So we have some number and it's times 1 to the x power. And then x changes, it goes from 1 to 2 to 3. This function here would never change because whatever the value of a is, it's times 1, it's times 1 again, it's times 1 again. And there's no exponential growth and there's no exponential decay. Now remember, it's growth if the base is greater than 1. That's this number right here. If that's greater than 1, even if it's 1.001, and you keep multiplying by that, your values are going to start to get bigger and bigger and bigger. But if the base is less than 1, namely a decimal between 0 and 1, then it's going to be decay. Okay, so we have two things we need to worry about, whether it's percent growth, that would be an increase. Let's write that down. That's going to be a percent increase. Or if it's decay, it's going to be a decrease. All right, let's see how it works. For each problem, create a function that models this scenario. So a Lego set is worth $100, and it increases by 23% each year. All right, now there's always going to be an initial value. So let's write out a function here, and we're going to use our function notation. So f of x equals our initial value. And then what do we multiply by? Well, it increases by 23%. So over here off to the side, what I'm going to do is I'm going to think about what this means. Let's go to this back up here. If the function has a 1 there, there's no change, right? And a 1 is a percent. How do we write that as a percent? That's 100%, right? So one whole is 100%. If we are 23% above 100%, so 100%, that equals 1 whole. And we want to increase that by 23%. So we're going to add 23%. So that means we're at 123%. What would that be as a multiplier or a decimal? That would be, you move it 2 and you get 1.23. Okay, so that's going to be our multiplier right there, 1.23. It is a 23% increase, so I know I go above 100% by 23%. That's going to put me at 1.23, and I raise it to the x power. Easy enough, right? Let's try the next one. A home is worth $200,000, increases by 1.5% each year. So, value of the home here, we have a function. We're going to start at 200,000. That is our initial value. And we go from 100%, and we're going to change that to 100. Well, we're going to add 1% and 0.5, so 1.5%. So this is going to go to 101.5. Now, if I want to write that as a constant multiplier, we move that, we get 1.015. 0.015. And that's raised to the x power. See how that works? Last one. This is decrease. This is going to be a percent decrease. So it decreases by 0.5%. And if it helps, you can think about this like it's money, like you lose half a cent. That means we have 99.5 cents, right? So this function here would be f of x equals, they start at 25, and we need to lose from 100%. So we're going to go down 0.5%. That's going to leave us at 99.5%, which if I write it as a decimal would be 0.995. And we raise that to the x power. So things to notice, if it's above the number 1, it's going to be an increase. But if it's below the number 1, it's going to be a decrease. And you have to measure the distance from 1 to find out what decrease that is. Okay, next type of question, very simple. We're just going to be given the equation here. Instead of f of x, they're using y. We're going to find the initial value. That's always first. Remember, that can be negative or positive. And the percent change is the distance above 1. So here we are 0.5. The distance above is 0.516. So if I write that as a percent, I move it over, I get 51.6%. And that is going to be an increase or decrease? I'm going to say an increase. right? Because we're going above 1. How about the next one? We're actually going down. So how far from 1 is 0.912? Well, that's 0.088. If you subtract, you can do 1 minus 0.912, and you're going to get 0.088. All right, so the initial value here is 8, and the percent change. All right, so this is what the decimal would be. How do we change it to a percent? We move it over 2. We get 8.8% decrease. We need to identify whether it's an increase or a decrease. Now, what do we do if it's a table? Well, tables. Come on now. Tables are easy. The 0 tells you where the initial value is. So at 0, it's at 150. So I know we have to start at 150. The percent change, we kind of have to figure that out. We get to this number here. So what did we multiply by to get to that number? So 150, I'm going to do a little equation here. 150 times something equals 153.75. Well, how do you solve that? You just divide. You take the second number, you divide it by the first number. So let's break out the calculator. So in the calculator, I type 153.75 divided by 150. I get 1.025. So the percent change, oh, that's actually the multiplier. It's 1. We multiplied by 1. I'm going to write this down up here. 1.025. That's what I multiplied this number by to get this number. So the question becomes, how much or how far above 1 is 1.025? And that is, you need to add 0.025. So if I change that into a percent, this is going to be a 2.5%. And we're going to say increase. Does that make sense? So we found that you have to multiply by 1.025. That's the multiplier. And you subtract 1 to find out how far above 1 that value is. And that tells you the percent change. It changed 2.5%. That's an increase. If we want to write the function, then we start with the initial value, which is 150. Our multiplier, which is 1.025. And we raise that up because it's exponential. All right, pause the video, try the next one by yourself. Go. Okay, how did you do with this one? Easy, initial value, 6. Now the percent change. Well, I noticed that when I worked this out, I did 5.1 divided by 6. It's getting smaller. So I noticed that what I'm going to do here, I don't want too many extra stray marks, but I noticed I need to multiply by 0.85. And that makes sense. So what's the distance from 1? You can do 1 minus 0.85. We get a percent change of 15. It's 0.15. That would be a percent decrease. All right, to write the function, f of x would equal our initial value times our multiplier, which is 0.85 raised to the x power. And that's how you create equations. How cool is that? Now, we probably should double check it by plugging in some of these to the equation. When you do that, you're going to see that it works. All right, number 6, Sully needs some cash. So we're going to cash Sully outside. How about that? Okay, he's going to start he's going to start a mobile phone service called Cellular Express. Classy, huh? That's classy. First month, he sold 190 cell phones. Since then, he's observed a 3.5% growth in sales. So let's create a function that models this situation. We're going to start with an initial value of 190 cell phones. And each month, it's growing by 3.5%. So we had 100%. We're going to grow by 3.5%. That is, if I change it into a decimal, 0.035. So I need to add that to my 100%. There's our constant multiplier right there, 1.035. And that's raised to the x. Now, some students get confused. They're like, why don't I just multiply by 0.035? That's if you want to find what 3% of 190 is, which is a very small amount. That's not what we want. We want to know what the growth is as we keep going. So it's going to go from 190, and the next value is going to be a little bit more than 190. Okay, if we use 0.035, it would be a very small number. It wouldn't be more than 190. We need to be 1.035. All right, so we need to find out how many cell phones he sold in his first 6 months. Let's just plug this into the calculator. We'll do it right now, not calculator. So you can type it in just like that. Make sure you use, we have our exponent button there for our exponents. We get 233.5585, which I'm just going to call that about 234. So to write this out, we have f of 6 is going to equal about 234 cell phones. Next question, if the growth continues, which month will Sully first sell more than 1,000 cell phones? So to do this, I'm going to teach you how to use your calculator, and that's going to be important. You're going to need to use that in this lesson as we're going through. You're going to have to use your calculator to do some of these. So why did I push the wrong button there? Here we go. Here's your calculator. We're going to go to y equals, clear out any information that's in there. So we know the function because we already created it. It's 190. So we're going to put that into y1, 190 times, and our constant multiplier is 1.035. Type that in. And that's raised to the x power. Make sure you use that x right there. And the question is, we want to know when that's going to equal 1,000 cell phones. So in our calculator in y2, I'm going to type 1,000. Now, just to clarify what's going on here. Here is the function that tells you how many cell phones Sully is selling. And this is 1,000. It's going to be a constant function. It's just going to let you know where 1,000 is. So if you hit zoom 9, not zoom 9. We don't want zoom 9. Take it back. Zoom 6. Zoom 6 is our standard window. And obviously you hit that and there's no functions on here. And so we've talked about this before. The values are way too tall. Like this is only going up to 10. He's selling 190. So to get a good idea of how many there are, I'm going to go up to the table here. I'm going to hit second and go to the table. And I notice that my values for Y1 go up to 250, 260. So I'm going to change my window. I have to go up to at least 1,000, right? I mean, that's the Y value. So I'm going to change my window so that the Y value is at least 1,000. So I'm going to go to 1,500. Okay, there's no right answer for this. You can go to 1,200. I'm going to 1,500, just something more than 1,000. For your X max, I'm going to assume he's going to have to sell quite a bit of or the number of, represents the number of months, remember, until he gets to 1,000. So I'm just going to crank that up a little bit. I'm going to go to 100 months. Let's look at the graph right now. And so if we do that, we've got a good looking graph, and we notice that they meet right here. This is almost perfect. That's nice. So second, calculate. We want to calculate the intersect, so we choose choice 5. We have to enter 3 times, and it tells us 48.27. So that is 48.3. The 48.3 third. Wait, how do we say that? 48.3. That's how many months? I don't know how to say that. I'm a math teacher. 48.3 months? How would you say that? Third? 48 point? Anyways, if growth continues, which month? So 48. In the 48th month. I'm just going to write it out like that. In the 48th month. Somewhere in the middle there. Sully will sell 1,000 cell phones. How's that? Perfect, huh? Number 7, the enrollment at the University of Massachusetts. Once again, clever. I'm on a roll today. It's currently 12,500, and it increases at a rate of 2.25% each year. All right, the population can be modeled by a function. Now, when we say modeled, we mean there's a function that can be used to estimate this. There's a function that exists that'll get us close Y values if we plug in X values. It's a tool that we use. So when you see the word modeled or create a model, it just means create a function or create an equation. All right, back to the problem. The population can be modeled by a function of the form f of x equals ab to the x. Well, that's just exponential. And x represents the number of years since 2012. That's going to be important later. So what are the values of a and b? Well, you have to use the information they give you here. Currently, we have an initial value of 12,500. So A is going to equal 12,500. And B is the constant multiplier, right? So B for here, it's 2%, 2.25% more than 100%. So that's going to be 102.25%. If I move that 2, I get 1.0225. That's going to be the value of B. Okay, describe what the value of the x-intercept represents in this problem. Ooh, x-intercept. That has me shook. Let's look at a little x-intercept here. There's x, here's y. So the x-intercept is where what? Y equals 0. This is where f of x equals 0. This is where the enrollment equals 0, right? So in this situation, the x-intercept would equal the point at which the enrollment would be 0. And maybe that's not possible with our function here. I didn't even graph it. Like, this is going to go down. Eventually, there's going to be an asymptote. It might never even reach there, right? It doesn't in this case. Never reaches there. But the x-intercept would represent where the enrollment would be 0. And the next one, describe what the value of the y-intercept represents. Well, the y-intercept is what? When you're going to get the y-intercept when x equals 0. So let's look at this function here. Let's write out the function. Here's what the function is right here. So f of x, if we write the numbers in, we get 12,500 times 1.0225 to the x power. Now, the y-intercept is where x equals 0. Remember, they're opposite. So this is where x equals 0. So if x equals 0 here, this turns into a 1 right here. So really, you get f of x, or f of 0, is going to equal 12,500. So what does that mean? X is 0. Let's go back up here. X represents the number of years since 2012. So the value of the y-intercept is where x equals 0. It's the time equal to 2012. It's 0 years since 2012. So how do we write that up? Here's the best way I can think. The y-intercept represents the enrollment at the year 2012, which is when this whole model begins. And here we go with our last question. This is a good one. Mr. Brust purchases a fancy, it's fancy, I tell you, fancy new car, a Mercedes-Benz. It's a new type of car. It's not really the same as Mercedes-Benz. It's a little cheaper, but, you know, it's what we can afford. We're teachers. He knows the value of the car will depreciate. Now, depreciate means goes down. All right. 12%, 12.25%. Okay, so let's write a function real quick to see what's going on. We have f of x. This is exponential, so we're going to have a value a, which we don't know. And we do know it's going down by 12.25%. So from 100%, it's going to go down 12%, 12.25. That's going to leave 87.75, which if I move the decimal to, will give me 0.8775. And the rest of the question says after 5 years, the car is worth about 3,400. So this will be raised to the x power. That's the time. It says find the initial value of the car. Well, we know that the value of the car is 3,400. And we still don't know the initial value. That's what they want us to solve for. But I know the multiplier should be 0.8775. And I do know that's after 5 years. So in our calculator, I can multiply this out. I'm going to divide both sides by whatever this number is. Let's figure that out. All right, we did a little math in the calculator, and we can see, we can kind of see here. Look, it's kind of getting, come on, move that over. Sorry, people. Sorry. Okay. So you can see that 0.8775 to the fifth power, that's this number right here. So here's what we're going to do. 3,400 equals a times that number there, 0.52027 ugliness, a whole bunch. It keeps going. And if I divide both sides by that number, which in my calculator is very easy to do, I'm going to divide and I'm going to get, hold on, there's just so many digits. All right, multiply that or divide that out. I get, when we divide, 6,534.97. So I kind of want to put it here, but there's no room. Math teacher problems, hashtag it. 6534.97. That is the initial value of the car. That's what A equals. Now, the question, when is the car going to be worth 20% of its initial value? Well, if I take this number and I multiply it by 0.20, that's going to tell me 20%, right? And why is the percent in front? Nobody knows this. All right, but 20% of the initial value is times 0.2. We can just multiply, that's shortcut, times 0.2, right? So that's going to tell me 1,306.99. Okay, 1,306.99 cents. We want to know when this function will equal that. So I'm going to plug into that function. So 1,306.99 is going to equal A, which we figured that out right here. So we're going to use that number. Times B, we know B is 0.8775. and that's raised to the x power. Now remember, x is the number of years. Each year you go up, it's times another 87%, which brings you down a little more, times another 87%, brings you down a little more. So if we can solve this equation right here, we can figure out the time at which it'll be 20%, and that's this number right here. This is the 20% number. So let's divide both sides by the initial value, 65. By the way, this is on the mastery check, and there's a couple in your practice that you need to do, but this type of question is on your mastery check. You got to know how to do it. So these cancel out here. We get 1306. I want to divide that. Let's pull that calculator up. I want to divide that by 6534. You know what's nice about this calculator? I can go up. I can grab this. Just hit enter. I want to divide that by this number here. So I'm just going to grab that. And you don't have to, worry too much about it. Look at that beautiful number. That is 20%. Boom. So 0.20 equals 0.8775 to the x. Now this kind of makes a little sense because they want us to know when it's going to be 20% of the initial value. So this value here is going to be 20%. It worked out nicely. We did our math okay. And now I just need to know how to solve this. How do I solve 0.8775 to the x equals 0.20? All right, well, little foreshadowing here. Check this out. I'm going to bring up the calculator. Y equals, let's clear these things out. We want one of them to be 0.8775 to the x power. Don't forget your exponent. We want the other one to be 0.20. So I'm going to do zoom 6. And remember, zoom 6 is my regular window. And you can tell, oh, man, they almost crossed right there. I'm going to fix my window a little bit. I don't need to go all the way up to 10. I can tell. And so if I only go up to like 4, let's look at the graph again. A little better. And I don't need any of the negatives. So let's change that. We don't need any of these. I'll just put -1. So you play around with the window until you get a nice looking graph. I'm going to have to go more to the right. So that's the x max value. So let me put in 25. We'll go back to the graph. And so after a whole bunch of playing, you notice that they do cross right about here. So I am going to calculate the intersect. So second, calculate the intersect is choice 5. Hit enter 3 times, and it's going to tell you 12.32. And that's how you solve this one. X equals 12.32. Now, depending on this equation, I mean, they're not all going to be like this. Sometimes the x is going to be right here. Sometimes the x is going to be right there, and you're going to have to solve it. But you already know how to solve those equations from before. So let's, hold on. When, years, boom, done. Got to finish the problem, right? Woo! Well, that's it. This is Mr. Kelly in K-Town. Good luck with this exponentially. Remember, it's nice to be important, more important to be nice. See you.